Graham. So as Graham made clear, artificial intelligence is developing rapidly. And there are lots of promises for researchers, but also I think for wider society. Today, I'm sort of the odd woman out on the panel, but I'm also the odd one out on the panel because I'm a social scientist. And I'm going to do something a little bit different and dial back from the sort of distant future scenarios of meta algorithms and creative AI systems and talk about some of my research that actually touches down in a sector that's really important to Canada in terms of GDP, but also to many Canadians, and that's agriculture. And I want to talk about not just sort of the long-term vision. In fact, I might not talk about that at all. I may leave that to the discussion period. So there is a long-term vision held by the Canadian federal government, held by industry, for a fully realized automated or smart farm in Canada. And as one example, this is obviously a people-less, a farmerless tractor that's already been piloted by Case H. And so there are those visions for the long-term future, but actually AI systems in terms of weak artificial intelligence systems, equipment that's passively collecting data from farms, so a tractor that collects data on soil quality, on environmental variables. Every John Deere tractor now does this, and it's a regularly used item for a farmer of a certain scale. It's called a precision agricultural piece of equipment. And so those tractors are fully in place, and they're collecting large data that then gets mined by weak AI systems to provide insights, mostly predictive, and advice to farmers, among other players, on when to seed, when to harvest, this kind of thing. So I'm going to talk about some of my research, speaking with designers, policymakers, and also a wide variety of farmers across Canada, looking at the use of these tools, these AI systems right now. Because I think that while future thinking is really important, and anticipating some of the large changes, say in the research domain, under a fully realized smart farm is really important. It's also really important to look at what's happening right now, and some of the risks then in doing so become visible. So maybe my next slide. Oh, do I have the? Sorry, I thought that was Raf. So I just wanted to, I'm not going to touch on all of these, but I wanted to give one sort of overview slide, and if you want, you could take a cell phone capture, or I'm happy to share my slide deck. Some of the potential societal risks are perhaps obvious from what we know about automation, for example, applied to other sectors like the automotive sector. In my research, it's becoming clear that a certain kind of agricultural labor is likely to be displaced by, say, automated milkers, or migrant laborers picking fruit are, I think, very realistically likely to be replaced at some point by an automatic picker. But at the same time, I'm finding in my research that at least right now, there's also a need, and this is a kind of risk actually, a need for a highly skilled worker in an agricultural system that's under AI. So for example, every John Deere tractor, the ones I mentioned, has a digital lock. And a farmer has to, if a tractor breaks down, the farmer has to, by legal agreement actually, they're licensing the tractor, they have to get a licensed expert out to plug in, something into a USB port and change code on the tractor. So that requires a skill set that typically John Deere dealerships didn't, and experts working for did not have. And farmers certainly don't really, by and large, have this skill set right now. As well, I'm finding that a lot of the artificial intelligence systems are in the stage where they need a lot of what's called ground truthing, and Graham spoke to this. So they're still requiring agronomic experts to get out into the field and make sure that these predictive algorithms are doing what they're supposed to do. So there's actually this need as well for a continued kind of human caretaker over these AI systems. I'm not sure how that's going to play out in the future. And to me, as a social scientist, there are interesting, I think, equity issues there, right? It's not just that we ought to be concerned, maybe as policymakers or as everyday people, about the displacement of labor in the agricultural sector, but we need to be concerned about how that might play out inequitably. Right? If we're talking about the displacement of migrant laborers and then not the displacement of people who are historically privileged, well-educated, for example, experts. I'm not going to touch on all of these. I wanted to frame some of the risks I will talk about. I just talked about labor, but under a kind of broader take-home message, which is that, to me, just alluding to the panel title, the promise and the peril of AI, at least as it's playing out in the Canadian agri-food sector, is not, the risks and the benefits are not being distributed evenly. And I think in terms of thinking about the ISSP role and the RCIS role, thinking about engendering innovation or innovation systems that create or contribute to equitable societies, equitable food systems, I think it's a really important thing to keep in mind. So I wanted to just give one example. So there's the technological unemployment, for example, right? That's a risk. But again, that's a risk that's not necessarily playing out evenly depending on where you sit, really, in the food system, what your expertise is and what your advantage or disadvantage is. I wanted to talk also about the issue of data access and how, again, the risks and benefits around data access might not be playing out evenly. So again, that was one of the things I highlighted here. So on the tractors that they're called precision agricultural tractors, again, that collect data from farm fields, a farmer can't access the raw data. As I said, most farmers don't have the digital skill set to do anything with the raw data anyway. But that, to some people, is considered a societal or an ethical issue, right? That lack of access to data that I'm helping to generate, one could consider that a kind of ethical issue. To me, what's sort of more interesting about the collection of data, in this case by John Deere tractors, is that those data themselves are quite valuable. And we all know this because of the collection of social media data, right? Every time we like something on Facebook, that can be enumerated, right? That's of value. And the same goes for agricultural big data. So John Deere, for example, collects those data and they can do things with them that create market value for the corporation. They also they give those data to third-party users. In fact, until recently, they were in a relationship with Monsanto Corporation / Bayer. And, there are potential benefits to the corporation, for example, in marketing, driving marketing strategies, that we might say are incommensurate with the benefits that are given to farmers. So, and we don't know. So one of the other issues is transparency. Just like with social media data, we don't currently know, for a host of legislative and technical reasons, what's done with the data. And so it's really hard to inquire into what's done with my personal data, who's benefiting from these data. Farmers, whether there are actual radical incommensurate benefits for the farmer versus a large agricultural corporation, we don't know. But when I speak with a lot of farmers, they have concerns about this. So whether it's a real issue is one thing, but that there are public concerns, especially among end users, is a real issue because I'm finding pockets of resistance. And we can think about historical agricultural technologies like GMOs and what GMO resistance really did. There are some economic failures because of wide-scale farm-level resistance to GMOs, for example, as one example. So farmers might benefit from the advice given from the collection of farm-level data, but I think it's very real that corporations also are benefiting. So, some farmers that I've spoken with have concerns that a corporation, for example, could set prices. So would know, for example, what's happening on the farm around a commodity and in the success of a particular commodity or in a region, right, given the collection of farm-level data, and would be able then to set prices of inputs like, for example, chemical pesticides in order to basically capitalize on any gain that would otherwise have happened at the farm level. And I think that, this is a concern for farmers given a historic trend toward what Tim Lang, a food studies scholar, calls the hourglass model for the food system in North America, right? A lot of concentration among input suppliers, whether we're talking about chemicals or machinery, and a lot of power among most corporations, and not a whole lot of power relatively in terms of market power among farmers who are in competition with farmers all around the world. So, those kinds of potential equity issues are a concern to me as a social scientist. I think, and just one last thing Graham mentioned in terms of reliability. One last sort of concern I have is around bias, not in the sense of reliability, like you mentioned, not in the statistical sense, but in the sense of omissions or exclusions in the design landscape around AI. What I'm noticing is that, there's a lot of high-level discourse at the World Bank level, the Canadian federal government, around the potential for a fully realized smart farm. So this would be not just the collection of data, but also algorithms that respond in real time, right? And equipment that responds in real time and varies the rate, for example, of the supply of water or an input based on what the machine is telling it to do. So while there's a lot of hope for those tools to help meet sustainability challenges, for example, through the reduction of inputs, what I'm finding is that sustainability is not necessarily the primary motivation of a lot of designers working in the private sector. A lot of those tools are being designed for large-scale farm operations, mostly in Western Canada. And the smaller agricultural or agroecological, operations or farmers of different scales are there's not a whole lot of incentive for the design and development of tools for those kinds of farmers who have been shown by the UN Food and Agricultural Organization, for example, to contribute to sustainability goals around food system. So I think that we need to develop models within the policy arena for incentivizing some other kinds of goals around AI in agriculture. Thanks.